This is trigonometry, section 4.5. So we're starting the second half of this chapter, and this section is all about the graphs of the sine and cosine functions. We'll have 3 more sections after this, and then we will have a test that primarily just covers 4.5 to 4.8. And I would say buckle up because today's lecture is definitely quite different than the ones that we've been doing so far. Yes, we still need to know right triangle trigonometry, SOHCAHTOA. Yes, we still need to know the unit circle. But since today is all about graphing sine and cosine functions, it's definitely quite different. So our objectives today, we're going to sketch the graphs of sine and cosine functions. You may want Desmos out in front of you or your graphing calculator. We're going to use some new vocabulary, or hopefully vocabulary that you remember from last semester, amplitude and period, which we're going to use. We're then going to talk about translations, both vertical and horizontal. And then to kind of wind it up, we do have a real world example. It's pretty messy. That's kind of how real world models are when you get to this point. But I'd like us to do it together in the lecture, as it is not a question on your homework. I'm not going to ask you to do such a messy real world example on your homework. So let's talk about the sine curve in general, and I would encourage you to get out your unit circle so that you have it in front of you so that we can kind of prove where these values are coming from, because when we graph values, we're not just making them up, right? They obviously are derived from something. So if you have your unit circle in front of you, what is the sine of 0? Okay, we're going to start with it looks like we're going to actually start, with our sine function here. What is the sine of 0? The sine of 0 is just 0. So that leads me to the coordinate point, 0, 0. So I plot that. What is the sine of pi over 2? The sine of pi over 2 is 1. So my next coordinate point, I know it's kind of weird to think of it, but my x value is the angle, and then my y value is what the sine value occurs, right? We're just focusing on sine today, or right now. What is the sine of pi? The sine of pi is 0, right? Notice how I'm plotting all these points. What is the sine of 3 pi over 2? The sine of 3 pi over 2 is -1, down here. And then we go back, we keep going back around. We're just kind of going around the unit circle counterclockwise. What is the sine of 2 pi? It's 0. Well, I can keep going, right? I can keep graphing this. I can then plug in, say, 5 pi over 2. Well, 5 pi over 2 is the exact same thing as pi over 2. So I have another point. So you'll notice that everything starts to repeat again. This is why sine and cosine are called periodic functions, because they keep repeating themselves over and over. Let's do the same thing for cosine using your unit circle again. So now we're looking at cosine. What is the cosine of 0? Well, it's 1, so that becomes my first point. What is the cosine of pi over 2? 0. What is the cosine of pi? -1. What is the cosine of 3 pi over 2? 0. And now we're back at the x-axis, so now since we've gone a full 2 pi around, what is the cosine of 2 pi? It's +1, right? And I can keep going and keep going and keep going, but ultimately you'll notice, right, I have now committed a full period of the cosine curve. So both cosine and sine have a period value of 2 pi, that's when they start to repeat, and their range, meaning what our y-axis, goes from -1 to +1 inclusive. So you'll see, right, that if I have them side by side, they look very, very similar. But let's look at our sine curve. What is our symmetry around, right? What is the symmetry around for the sine curve? Well, it is around our origin. So that makes sine odd, right? And just by visualizing, by seeing it, we can kind of determine, yep, it's odd. Whereas what is our symmetry for cosine? It is around the y-axis. So that makes it an even function. So even though they look very similar, really, right, it's just kind of a phase shift of pi over 2 difference, they are slightly different. So we just have to make sure we know the difference between the two of them. This just kind of, again, outlines our symmetry and why we have odd and even. So some points, right? So since today's learning target is all about being able to graph these functions, there are some key points that we want to look for, namely our intercepts, meaning our x-intercepts, y-intercepts, right, as well. We're also going to want to look for our maximum points. There's a maximum. Here's our maximums over here. And then we're also going to want to look for the minimum point. So we need to make sure we have enough of these points so we can really draw the shape and know where the shape starts and kind of ends before it starts repeating itself. So let's do our first example where we'll graph these things, okay? And as we go through these, I think it's kind of the easiest way to kind of show you how all of these things are determined, how we figure out how high we go up, whatnot. So the first thing I notice is that it is a sine curve, okay? It is a sine curve. I'm not adding anything on the end. I'm not adding or subtracting anything inside parentheses. So this is pretty straightforward. This is going to look exactly like our other sine curve, except, right, I have this 2 out front. So I've got to work on that a little bit. How is that going to change my sine curve? Well, the way that it's going to change my sine curve is that the 2 is going to represent our maximum value, and our -2 is going to represent a minimum value. So our range is, instead of going from -1 to +1, is going to go from -2 to +2. And this becomes an important number, this number in front of the word sine or cosine. It represents our amplitude. So that's one of our new vocabulary words today. Hopefully we kind of remember it from last year. But let's go ahead and graph this. And it says to graph it from -pi all the way up to 4pi. So we got a lot going on here. So I'm going to come over here and I'll do -pi, and then I'm going to do halfway in between to do -pi/2. Here we have 0. Hopefully I've spaced this out enough. I'm going to do pi/2. Oh, I may not have. Pi, 3pi/2. 2pi. Let's keep going, okay? I'm going to do 5pi/2, 3pi, 7pi/2, oh, kind of fit it, 4pi, right? And I'm making us draw this much because I really want to make sure we see the function and see how it repeats. So our sine curve at 0, we have a sine value of 0. So I'm going to start there. Now at pi/2, I know that I go up, and normally I go up to 1, but now I'm going to go up to 2. So on my y-axis, I've got 1 and 2, and then down here I'll do -1, -2. So at pi/2, I'm going to go up to 2. At pi, I'm down here at 0. At 3pi/2, I'm down here at -2. And you'll notice you can just kind of, graph, okay, then the pattern is going to repeat itself. There we go. Now over here, I want to keep going, right? So since I go up, that means this one must go down. And then here we're at 0. So now go ahead and do your best to kind of graph it as a nice little sine wave curve. Ooh, ooh. Let's see if I can undo that. Okay, I'll try again. I will try not to hit the button on my drawing pen here. Not the best, but we got our sine curve there. So that's what I'm going to be looking for as we graph these. So amplitude and period, I know I already kind of mentioned that, but let's formally kind of determine what that is. So here's the thing, your book likes to put this value out in front. I like to put this value out in the back just because I think it aligns more to how we learned last year. Remember, if I add something, I can add it in the front, I can add it in the back, it means the exact same thing. And especially because it's D, I really don't understand why they don't do it in the back. But so this is kind of our generic sine and cosine curve. And notice I've got all these different letters in here. So I want us to really talk about what these letters mean. And for the most part, I think we kind of know what some of them are. I will say kind of what's going on in here in the parentheses may seem a little bit overwhelming. So we're going to talk about those quite a bit more. So the A value, the number that's in front of the word sine or cosine, that absolute value of A equals my amplitude. A is also going to tell me whether or not it's reflected in the x-axis. So if A is negative, it's going to be reflected in x-axis. And hopefully that makes sense, right, to what we learned last year. If I've got a negative out in front, I'm going to see a reflection in the x-axis. A is also going to determine, because it's your amplitude, it's how high up you're going on the y-axis or how low you're going on the y-axis. That's going to determine your vertical stretch or shrink, right? It's your dilation. So A tells us a lot about the function. We can learn a lot about how we're going to graph these. The B value, this is one that we really have not covered yet, may take a little bit more time for us to practice with. B is going to represent a horizontal stretch or shrink. Okay. C value, so think about when we have something inside the parentheses. Remember, if we add or subtract something inside the parentheses, that represents a horizontal translation, right? We're going to move right or left, and it's going to be the opposite of what you think. Just like before, it's the opposite of what you think. So if I have a negative inside here, I'm going to be going to the right. If I have a positive inside here, I'm going to be going to the left. And then the very last piece that I like to cover is the plus D at the end. D is going to represent your vertical translation, up or down. And that makes sense, right? If we just tack on something at the very end, I'm going to figure out what the sine curve looks like, and then I'm going to move it up or down. So let's go ahead and look at some more examples as we go through this. And let's make sure we really kind of define amplitude. So your book, right, defines here's your amplitude, maybe something in your notes that you kind of want to, star, make sure we know about, because we want to make sure we just look at the value out front. Because remember, it could be reflected over the x-axis. I just want to take the absolute value of A. So that's going to kind of represent that middle line for both your sine and your cosine curves. Meaning, right, say your amplitude is 3, your sine curve is going to go up to 3, down to -3. So you're going to have 3 up here and then 3 down here. So really, your sine curve covers a whole 6 units, but you've got some going up and then some going down. So let's sketch some things by changing the amplitude. So the first thing we're going to change is just the amplitude. And I don't think we need to go all the way up to 4 pi. Let's at least go up to 2 pi. So I'm going to label my x-axis. And you'll notice I haven't labeled these for you. I really kind of want you to take the time to learn how to label these, to understand where these values are coming from. I usually, have students do this because I do think there's some value in kind of forcing you to do it. Now, looking at this one, we're going to be graphing cosine, so it's going to be a little bit different than sine. My amplitude over here is 1/2, whereas my amplitude for this guy is 3. So as I fill in my y-axis, I want to make sure we go all the way up to 3. So we'll do 1, 2, 3, and then I'll kind of put my half tick marks in there. And then I'm going to need to do the same thing down here. And I'll put my little half tick marks there so I know. Okay, so let's do cosine first. And maybe I'll do cosine of 1/2. We'll do 1/2 cosine x first. We'll do that in red. So the cosine curve, remember, that doesn't start at 0, 0. It starts up. It starts up higher. So we're up here at the 1/2 point. Instead of it being 1, which is a regular cosine curve word, we're at 1/2 cosine, so we're there. Pi over 2 would be 0. Then we're going to come down to -1/2. This is kind of a super tiny one, right? And then back up to 1/2 at the end here. And then let's make sure we kind of graph the rest of these down here. Here we go. So go ahead and draw that. Kind of looks like a bit of a straight line. There we go. Okay, so there's our first cosine curve. Now our next cosine curve, I'll do that one in blue. It's going to have the exact same kind of points, but we're just going to vertically stretch them by 3. So I start up here at 3. I'm still going to be here at 0, but then down here I'm at -3, 0, and then 2 pi back up here to 3, here, and then down to -3. There we go. And there is our cosine curve. Got to make sure it looks like it's going to come back around. There we go. All right, so we've done that by changing the amplitude, and we had to find these points, right? We needed our maximums, we needed our minimums, we needed our intercepts. So finding all of those key points is important when being able to draw these curves. So if I tack on a negative on the front, right, here's our cosine curve is in the light gray, and then in the dark black, we have -3 cosine. All I'm really doing is I'm taking each of those points and I'm reflecting them over the x-axis. Okay, now let's talk about all the stuff that was kind of inside the parentheses, right? We had a cosine bx minus c plus d. So let's talk a little bit more about kind of this stuff that's going on in the middle. The first is, what do we do with the b value? So the b value is going to let you know how long the period is. The standard period, right? Think about when I go around the unit circle, how big is the unit circle? It's 2 pi. Once I've gone around the unit circle, all my sine and cosine values just start repeating again. So the standard period of a cosine or sine curve is 2 pi. If I change that up, then I take my b value and I say, okay, I can figure out the new period by doing 2 pi divided by that b value. Okay, so now, and by doing that, you're going to horizontally stretch or shrink. If you wind up with a value that's greater than 2 pi, then we would say we have stretched the cosine curve out. Whereas if you have something that's less than 2 pi, we call that a horizontal shrinking. We're kind of pushing all of that stuff together, and we may have a bunch more cosine or sine curves in that 2 pi area. When b is negative, right, it really just refers to, because you'll say, well, what happens if I have a negative inside the parenthesis, a negative attached to the x value? Well, really what that does is it depends on the curve, right? The sine of negative x is negative sine x. That's just reminding me that sine is an odd function. Whereas the cosine of negative x is still cosine x. That's just reminding me that we have an even function. So it's kind of like what we do if we have a negative b value, we kind of just move that negative out front. And if we have a negative b value with cosine, we just ignore it. And that's because of the rules of odd and even functions. But like I said, I know this is quite different. Really the pattern recognition, being able to graph these functions, I highly encourage you to use Desmos to double check your work, is really to just make sure like you see these patterns. It takes the time to graph these. So let's do a graph where we haven't changed the amplitude. The number out in front of my sine curve is 1, so that tells me my amplitude is just 1. I'm really just going to go up to 1 and down to -1. But now I have a b value. I have a value in front of the x. And you're going to say, well, it's below the x. Remember, x over 2 is the same thing as 1/2 x. So my b value is 1/2. So if I want to figure out my period value, in order to figure out the period, I do 2 pi divided by b. And remember, dividing by 1/2 is the same thing as multiplying by 2. Yes, I'm sure I could hear you saying that. So my period value, the time it's going to take to complete one full sine period, is 4 pi. So now this time I definitely have to go all the way out to 4 pi. So we've got pi over 2. Pi, 3 pi over 2, 2 pi, 5 pi over 2, 6 pi, 7 7 pi over 2. Oh, sorry, that should, not a 6 pi. That's 6 pi over 2, which simplifies down to 3 pi. Okay, so we've got this, and we know we're going to go up to 1 and down to -1. And remember our sine curve. Just try to remember at this point, okay, does sine start at 0 or at 1? It starts at 0, and then I want to make sure I only do one full up, down, up by the time I get to 4 pi. So I'm going to have to say, okay, normally by pi over 2, I'd be up here at 1. Now that has shifted over. It's going to take me all the way to pi to get to the value of 1. And then when I come back down, it's going to take me all the way to 2 pi to get there. And then at 3 pi, I'm going to be at -1. So here's kind of how I've stretched out my sine curve. Because it's now taken 4 pi, we call this a horizontal stretch. We're stretching out the sine curve. It now takes a full 4 pi to get there. All right, if you're with me right now, that's a great indicator that you've got this. Now we're going to start to add in some translation. So let's see what we talk about when we talk about horizontal translations. So to remember when we kind of covered, say, quadratics, right? We started with an x squared, and then what happens if I put an x minus 2 squared in there? Remember, it was inside the parentheses, so that tells me to go left or right, and then it was the opposite of what we thought. So since we have a -2 in here, that told me to go right 2 units, and I'm still just graphing the quadratic x squared. So that's the exact same thing that we have in here. We look at our c value, and I really think it should have a plus or minus in here, because really it could be a positive number, it could be a negative number. That's going to tell you how to shift horizontally left or right, and it's the opposite of what you think. Okay, so what's going to kind of bug you, because with x squared, we just kind of have the same points and we just shift them over 2 to the left or right. With sine curves, we know everything just repeats, right? We just keep having the same thing. And so how do we know where to graph these things if we're going to be shifting left or right? Well, you can kind of use this rule of thumb. You can use Desmos. You can do a lot of different things. You will complete one full cycle of whatever curve you're studying, sine or cosine, if you plug into these equations and solve. Now, the problem is sometimes when you plug into these equations and solve, you might say, okay, so I'm going to do one full cycle from -3 to -2. Okay, well then that tells me from -2 to -1, I'll be doing one full cycle. From -1 to 0. It really just helps you to verify, okay, what is the period? Where's a good place to start graphing this? And students are always looking for formulas, like how do I do this? Just give me the formula. This is a formula that you can use again and again if you're having a little bit of difficulty trying to figure out the phase shift to use. Right, so here's kind of what your book is telling you. Your left endpoint, your right endpoint, your period values here. I wouldn't recommend memorizing this formula. If you're going to memorize the formula, I would memorize these two. You're just going to plug what's inside the parenthesis equal to 0 and then equal to 2 pi, and you're going to solve. Remember, this is going to have numbers in it. We'll do an example to show you. But the one that you may want to remember is that C divided by B is your phase shift. And the phase shift really just stands for your horizontal shift. How much are we moving from our original function that we're used to? Here kind of sums it up. They're trying to add more and more to this box, right, as we kind of go through all these things. We have our amplitude, we have our period, and then here we have the left and right endpoint. So here, we've added more stuff. This is a good box to kind of summarize so far what we've learned. So let's look at a couple of examples. The next 4 examples are quite a lot, so just hang on. And if you want to, a good thing to do is maybe to pull up Desmos. So if you pull up your Desmos, because you're going to say, well, Desmos doesn't have pi over 2. It can. By default, Desmos is going to be in radians. If you click on the little graph setting, and for your x-axis, if you type in pi, It'll change it to pi, pi divided by 2. So you'll notice if I put in sine of x, it actually is going to show me kind of exactly what we've been graphing within our notes. You can kind of zoom in a little bit if you want there. See? So I can see it, the x-axis in the terms. And what I did, as a reminder, I clicked on the settings, and for my x-axis, my step value, I changed it to pi divided by 2. That's just a little trick that'll help you out as you're graphing these. So let's look at, so it doesn't have us graphing this, it really just has us analyzing this function, which I think is a good way to start. Let's just try to break this down a little bit. And let's talk about the things that we know. The first is, let's just identify what our A, B, C, and D are. So the number in front of the sine curve, that's your A value. The B value is your number in front of your x, so it's just 1. Your C value is that pi over 3. And then the D value, am I adding or subtracting anything out here? I am not, so that's just 0. So let's fill out some information. We know that our amplitude is 1/2. So that tells me the range, because I'm not adding or subtracting anything on the end, is going to go from -1/2 to +1/2. So I can kind of get an idea what this graph would look like. My period value, well, that's 2 pi divided by b, and since my b value is just 1, it's 2 pi. Now, the C part, that's going to be the hardest one. So I know that I've shifted. I've got a negative pi over 3. So that tells me I have shifted right by pi over 3. The problem is, I'm not using pi over 3 on my x-axis. I've been using pi over 2s. So now I've got to kind of rethink this a little bit. Well, let's use the formulas that they've given me. Let's use our left and right equations to kind of pull this out a little bit. So I'm going to take what's inside the parentheses first, and I set it equal to 0. And then I solve for x. I just add pi over 3 to both sides. So I get, if I'm going to start a cycle, this would be where I would start cycle at pi over 3. Now we take what's inside the parentheses, and this time we set it equal to 2 pi. So again, I have to add pi over 3 to both sides. So I've got 2 pi plus pi over 3. I'm going to multiply this. It becomes 6 pi over 3. I get 7 pi over 3. So this is where my cycle ends for my sine curve. So between pi over 3 and 7 pi over 3, that's where I'm going to complete the full period for this new function that I've graphed here. So in order to figure out kind of the points, I say, okay, I'm going to divide pi over 3 to 7 pi over 3 on my x-axis into 4 equal parts. And that's going to tell me what the points that I need to be able to graph on my x-axis to be able to complete the sine curve. But for the most part, just in terms of analyzing the function, I think we've kind of hit all the important points that we need. Now let's do an example where we do actually graph it. And this time we're looking at a cosine curve, right? Notice we're kind of jumping around. Cosine, sine, cosine, sine. All right, first things first, I have a negative out front. So that tells me this cosine curve is going to be reflected in x-axis. My amplitude, my A value, is -3, so that tells me my amplitude is the absolute value of that is 3. So the highest I'm going to go on my y-axis, my range, notice I'm not adding or subtracting anything outside of the parentheses, so my range is going to go from -3 to +3. So that's kind of going to tell me what to put on my y-axis. So let's do that now. Okay, let's fill out some more information about this. My b value is 2 pi. So that tells me my period is 2 pi divided by b. That's just 1. Notice I don't have any radians here in my answer. So maybe I'll just, maybe I'll make 1, 2. Over here I'll do -1 so I can graph as much as possible there. So that's kind of interesting. Now let's figure out if I want to start or end a cycle. So I'm going to do 2 pi x plus 4 pi equals 0. And I want to solve for x. So I subtract 4 pi, divide by 2 pi. I get x equals -2. So this is where I would start my cycle. All right, that tells me, sorry about that, but we're going to go ahead and remove these. If I got to go to -2, I need to be able to fill that in. So that'll be -1, -2. We'll make this 1, 2, 3, 4. Okay. See, sometimes you just don't know till you know. So that's where I start my cycle. Then I'm going to take this and set it equal to 2 pi. I subtract 4 pi, so I get -2 pi. Then I divide by 2 pi, so I get x equals -1. This is where I end my cycle. So see how like doing all of this is going to be like, okay, I know that I have a period of 1 that's going to help me set up my x-axis. I know it's reflected in the x-axis, so I've got a lot of moving pieces that I have to remember. So normally for a cosine curve, I would start up here, but since it's been reflected, I'm going to start down here. Now what I want to do is I want to break this into 4 equal parts. Right? And since we're not dealing with radians right now, we're just working with decimals, I've got -1.25, -1.5, -1.75 if you would like to label them. But this is just going to help me. I guess I kind of drew that a little bit low. Do that a little bit higher. -3 there. That's going to help me to plot these other points. Go all the way up here. Go all the way here. And then for a cosine, I kind of end where I start. And then I may want to keep repeating that, right? Oop. Oop. Right. And one too many. You can kind of draw as many of these as you kind of get the gist of it for. 1, 2, 4. All right, that's probably enough. Now I'm going to do my best to connect these dots. Notice, right, with having such a shortened period, there is my cosine curve. Whew, a lot going on there. But you've got to take the time to do it. But remember, we can always jump over to Desmos and plug this in, right? So let's go ahead and do that. -3 cosine. And you can just type in pi, it will change it around, plus 4 pi, close parentheses. And you'll notice now it doesn't really make sense for x-axis to be in with a step of pi, so maybe I'll change this back to 1 and make sure, oh yep, goes up and down between -2 and -1. I'm showing the exact same thing. Right, moving on, let's look at example 6. So the last type of transformation is kind of the easiest one, I think. It's one that we've covered quite a bit. I don't know, again, I don't know why they put the plus d in the front. I'm going to move it to the back. If you have anything that you're just kind of tacking on at the end, that you're adding, that's outside of the parentheses, it's going to be a vertical translation up or down, and it's exactly the direction that you think. Right? So if I'm going up, this is going to be positive. If I'm going down, this is going to be negative. So let's look at an example here. This is kind of our last one that we'll be graphing. You know, we did a lot of graphing today. So first, it's a cosine curve, right? I need to make sure I know that. My amplitude, that's 3, the number right in front of the word cosine. My period value, I'm going to take 2 pi divided by the number that's right in front of the x, which is 2. So that tells me my period is pi. So I'm going to have a lot more of these within a shorter period of time. And then my vertical translation is going to be up 2. So if I want to think about what my new range value is, right? Normally with an amplitude, of 3, we would go from -3 to +3. But now I'm going to be going up 2. So my new range value is going to be -1 to 5. So when I plot this on my y-axis, right, I need to go -1, 2, 3, 4, 5. That is kind of where my cosine curve is going to go. And I'm going to break this up. Knowing that my period is just pi, I'm just going to do pi over 2, pi. So by there, I should complete a full cosine curve. Then I'm going to have 3 pi over 2 and 2 pi. Right? And if I want to break this down into fourths, here I have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. That's just kind of to remind us that we've got to break those down enough. So cosine starts up high or low, depending on if it's been reflected. And then I've got to figure out what is halfway between -1 and 5. Well, 5 plus -1 is 4, divided by 2 is 2. So my average, my halfway point is right there at the point 2. And then I come down to -1, and then I go back up to 2, back up to 5, down there. Right, so kind of my new x-axis or my new middle point is going to be right there at 2. And then last but not least, my 2 pi's up here. And then go ahead and draw your cosine curve. All right, I know that we've covered quite a lot, but if you can stick around and put up with it, I'd like to go over the mathematical modeling question. It is quite a tricky one because honestly, when you start working in the real world with these numbers, they get challenging. They are very, very challenging. So the table shows the depths in feet of the water at the dock at various times during the morning. So think about the way the ocean works, right? Your tide goes up, your tide goes down, your tide goes up, your tide goes down. So therefore, the depths are going to have that period type function, which is just like a curve. So we've got these here, and thankfully your book has nicely plotted them for you. So we have a graph over there on the left-hand side, and we want to figure out some information. We want to say, okay, using this information, I have a feeling, right, it's going to keep repeating itself. Now notice that because of the data points in the table, it's not perfect, right? And that's how real world data works. It's not going to be exactly like a cosine curve every single time. But I would encourage you, if you get a question like this, and it's kind of a challenge question or an extra credit question or something like that, the first thing you should do is really graph the data. Now, when I graph the data, it's kind of hard to see. This could be a sine curve. It could be a cosine curve. You really can use either one. And your book encourages you, well, let's use a cosine curve and let's start kind of figuring out what all of these little pieces are, right? I've got to figure out what my A value is, my B value is, my C value is, and my D value is. And once I've done that, I have modeled this using the data provided for me. So let's first start with amplitude. If I want to figure out the amplitude of the function, I'm going to do 1/2 times the maximum minus the minimum. So our maximum depth is 11.3, our minimum is 0.1, so when I find that and I take the average or the halfway point, it's 5.6. So that tells me that my amplitude is 5.6. I have my A value, so I can start filling that in within my cosine function. Now the next time is trying to figure out how long does it take to fill a complete period? How long does it take for the cosine function to start repeating? Well, looking at our graph, we don't see a full cycle, right? We don't see the full thing, but we can see that it does a half cycle between the times at which the maximum and the minimum depths occur. So if you look at your maximum, that occurs at 0.4 or hour 4, whereas your minimum occurs at hour 10. So between 10 minus 4, it's going to take 6 hours to do a half, So therefore, the full period, you just have to multiply it by 2. So it's going to take 12 to do a full period. So your period value is going to be 12, right? Or that's how long it takes in terms of hours. So now we want to plug that into our function. Like if that is what the problem, if that is what what we're getting as our period, well, what is my b value? Well, in order to calculate that, right, I've got to do 2 pi divided by 12. And since we're looking at real world data, to be honest, I think we could keep it as pi over 6. Your book encourages you to use 0.524, but I might just keep it as pi over 6 as we do this, so that we know that that's going to kind of be the importance there for our function. Because high tide occurs 4 hours after midnight, our left endpoint we can consider to be 4. So our C value is going to be approximately 2.094. Okay. And think about it, like where did they get this formula here? Think about it this way. We have bx minus c equals 0. I want to solve for x. So to do that, I add c. I get x equals c divided by b. That's where that is coming from. Okay, and since we have our b value at 0.524, I'm going to take my, right, I'm trying to figure out what my c value is. So I get 4 equals c divided by 0.524. And when I multiply both sides by 0.524, that's how I get this 2.094. Okay, although, let me just, I get 0.296, to be honest. I was looking at my answer sheet and it's like, I get 2.096. So that's our b value that we have. So let's go ahead and write out our cosine curve as we know it right now. We have y equals, now let's remember what's our amplitude value, 5.6 cosine. And I think I'm going to use pi over 6 as my b value. So pi over 6 x, or t, I know they're using t, minus 2.096. So here is the equation that models it so far. Now the last thing we have to think about is, did we go up or down? Let's look at our curve. We did, right? So I'm thinking, okay, if here's my maximum, here's my minimum, how do we figure out kind of how much we have shifted by, right? Because we're just going to look at kind of in between, right? 11.3 was our max, 0.1 was our minimum, 5.7 was kind of our shift there. So we can model it by just tacking on a 5.7 at the end. So we get y equals 5.6 cosine pi over 6 x minus 2.096 plus, notice how very, 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 very challenging that question was, right? There's a lot of moving pieces. This is something in the real world, if you're modeling this, number 1, you'd hopefully have a computer doing this modeling for you, or number 2, it would be you and a whole team of people trying to come up with these models. So let's look at letter B. B is a little bit more easy because it's saying, all right, now let's find the depths at 9 a.m. and 3 p.m. So now we're going to take this equation, remember that should be a 6, not a 4, and we're going to just plug in different values. We're going to plug in our x is equal to 9 and our x is equal to 15. Why would it be 15? Well, remember, we're kind of thinking in military time. If we start at midnight, this is going to be 15 hours after our modeling occurs. So that's why we have to plug in 15. This is the type of question that I would expect you to do if I gave you an equation that modeled the situation given to us. So hopefully you're not feeling too overwhelmed. I know that was quite a bit, but I thank you for your time. That concludes 4.5.